right? Because it's always been x squared. Well, today what's going to happen is you're going to see that the a value is not just a 1. So you're going to have to think, for example, let's look at this one. This one, whenever I go to factor this, I'm unfoiling it. So the first term times the first term has to get me 4x squared, right? So you have two options. You have 4x and 1x, or you have 2x and 2x, right? So that's what makes this a little bit more difficult, is that we don't know which numbers to put in. That's why it's called trial and error, guess and check. You're literally going to pick, I'm going to put 4x and 1x and then just try it. And if that doesn't work, then I'm going to erase it and do 2x and 2x. You definitely want to use pencil for this, not pen, okay? Because you will be erasing as you go. All right, so that's what we're going to do. Factor by trial and error. You need to unfoil this expression. So you want to list the factors of the first term, which this one is kind of easier. The only options are 3x and 1x. That's it. Okay. You also want to list the factors of the last term. We're no longer saying what multiplies to 5 and adds to 16, because you also are going to have this 3 that's going to get foiled in. Okay, so that's why this makes it a harder guess and check. So the factors of 5 are either 1 and 5, or -1 and -5. And then you literally just set up a template and you start trialing and erroring, plugging in numbers. And then you check by foiling. Now the nice thing that we do have about this one is there's only one option. 3x and 1x. Like, you could write those in permanent marker. Those aren't going to change in this example. Now, you have to play around with, of course, you want to use your context clues. When I foil this, I want it to be a -16. So, like, I'm definitely picking the negatives. But the 5 might go here and the 1 here, or the 5 here and the 1 here. So you now have more guessing and checking. But for those of you that are good with number sense, you're going to think about the foiling process as to, like, which one's going to get me -16. So obviously, I want to do 3 times a -5. So I'm going to put the -5 here. That'll get me -15. And then if I put the -1 here, when I foil this will get me -16. Or -1, which will get me -16. Now, when you check with foil, you really don't have to do the F or the L, because we've already ensured that the first terms are going to multiply to get the first term and the last term. So you really only have to check the O and the I of foil, which are the outers and the inners. So it's just a little bit less work. If you want to do all of foil again, you can. But this will get me a -1x, and this will get me a -15x, and I can see that that indeed, when I add them together, gets me a -16. So I'm done. That's my answer. Okay, the next one. Unfoil this. The first terms have to multiply to be 2x squared. So that's 2x and 1x. That's the only option. Now for 12, we have quite a few options. We have 1 and 12. We have 2 and 6. We have 3 and 4. And of course, the order in which you plug those in will make a different polynomial this time. So we set up our template, putting in 2x and 1x, because that's the only option, which makes this a little bit easier. And then now, you can use kind of your brain to think about which number is going where before you write them down. But if you are someone that doesn't see it very easily, you could just pick numbers and start. I don't know, let's start with 2 and 6. So if I plug in a +2 and a +6. Again, I'm checking this by checking the O and the I of foil. So this will get me 2x. 6 times 2 will get me 12x. That's going to get me 14, which is not 11. So this is wrong. So it's up to you whether you want to just switch the 6 and the 2 first and then eliminate that as a pair completely, or if you want to switch it up and go to 3 and 4. I'm going to go to 3 and 4. So let's put 3 here and 4 here. And that's a guess also. I don't know where 4 and 3 are going. 3 times 1x will be 3x. 4 times 2 is 8x. 8 plus 3 is 11. So that's my answer. Again, some of you will be really good at this really fast. I can show you 2 examples and you'll do it fine. Some of you will struggle for this because you don't see how the numbers are multiplying in your head. You'll take a little bit longer to check. Okay, now these, and obviously as the numbers get bigger, the more possible combinations, which can make it harder or more time consuming, I guess. So the factors of 4 would be 4x and 1x, or 2x and 2x. And there's no way to know which one to start guessing with. Okay? Except to think logically through your number skills. So one and 3 are only factors, so that does make it a little bit easier in terms of the number of combinations we have. We know it's not going to be -1 and -3 because it's a positive in the middle term. What do you want to start with, 4x and 1x or 2x and 2x? Doesn't matter. Abby? 4x and 1x. And then we're going to try plugging in the 3 and 1. Again, you probably want to think through it a little bit in your head first. If I put the 3 here, that's going to get me 12, and that'll get me 1, which is never going to get me 7. So let me try that the other way. Let's put the 3 here, the 1 here, and that's going to get me a 3x. This will get me a 4x. When I add them together, I do get a 7. So we lucked out. Sometimes you luck out on your first guess, sometimes you don't. Okay, the next one, also a little bit harder because we have 6, so the factors would be 1x and 6x, or 2x and 3x. And then our factors of 35 would be 1 and 35, and 5 and 7. Now when I look and see, my FOIL answer I want to get to in the middle is a negative, which means these are both going to be negatives. So otherwise I won't ever get a negative number. So then we set up our template. Again, not really a way to know what numbers to plug in. I'm going to try 3x and 2x first. And I, for some reason, always usually pick the numbers that are closer in distance to each other. I don't know why. It doesn't always work, but I pick these because they're closer instead of being 6 and 1. But you can see that one, the 4x and 1x works. Let's try the 7 and the 5. So let's put the 7 here and the 5 here and see what happens. So we'll get -14 and -15, which will get me a -29, so that doesn't work. Take an erase. But before you eliminate the 7 and the 5, try switching them. And this will get me a -10x and a -21x, which gets me a -31. All right, I want you guys to try the next two on your own. These ones are actually kind of a review of some of the stuff we did yesterday mixed with today. You do want to remember still, when you get to these problems, you want to look for a GCF first. On the front, we didn't have any GCF in any of them, so I kind of skipped over that, but you do want to look for one first because it makes the problem significantly easier. So the GCF for number 8 would be 5. So I'll factor out a 5 from each term. And then, see if I can factor this further. Well, yes, this is the difference of squares. So we'd have x plus 2 times the quantity x minus 2. Okay, now the reason I put these on the notes is that before you start writing 3x times 1x and 1 and 27, 3, 9, look for a GCF. Each of these is divisible by 3. If you take out the 3, it then becomes an easy factoring question where you don't have to do as much guessing and checking. Once you have an A value of 1, this is easy. You're just saying numbers that multiply to get me 9 and add to get me 6. Because when you do your little template, it has to be x and x. And when it's just x and x, you don't have to think about foiling it all out every single time. So two numbers that multiply to 3 and add to 6 are positive 3 and positive 3, which we could write as x plus 3 squared. Okay, why don't you guys try 10? Again, look for a GCF there. And then also try the two closures. So try these 3 problems.